I started out with x squared plus y squared is equal to 4. So I started out with a circle. So I do the first derivative, and so it is going to be 2x plus 2y dy dx is equal to 0. So that is the first derivative. It's equal to 0 because the derivative of 4 is 0. It's a constant. Now I'm going to move everything over to one side and solve for dy dx. So dy dx is equal to, and I end up with negative x over y. So that is the first derivative. How many of y'all got that first derivative?
Yeah.
Okay, that's okay. It's okay if you didn't. It is totally fine you didn't. You have 24 hours to fix that.
That is very reassuring.
Oh my gosh.
I'll be in my office today if you need extra help.
Yeah.
Okay, now I'm going to do the second derivative. Now when I do the second derivative, I'm just going to rewrite this as negative xy to the negative 1 because I like the product rule more than I like the quotient rule. So d2y dx is equal to, the derivative of negative x is just negative 1 y to the negative 1. So I'm doing the derivative of x first because it's the product rule. And then it's going to be minus 1 y to the negative 2 dy dx, and that's still multiplied by that negative x. So I did the derivative of x first, and then I did the derivative of y to the negative 1. And so I end up with negative 1 over y, and you didn't have to do that part of it. If you didn't do that part of it, that's cool. And then the double negatives make it positive x, and then in the denominator I get y squared. I do need to replace my dy dx with what I found dy dx to be, which I found it to be x, negative x over y. So I replace that with a negative x over y. So my final answer in some form of this should be negative 1 over y minus y squared over y to the third. How many of y'all got that, or something similar to that? You got 24 hours. Let's talk about it. What went wrong? Where did it go wrong? Where did you have hiccups? What was the problem?
Second part of the derivative. Second step.
This part here?
No, the one below that.
This one here?
Yeah. I messed up there.
What part? What happened to make it mess up?
I did not replace dy dx with negative x over y.
Okay. That's an easy fix.
And what happens if we end up it?
What else? What else was the hiccup? Where else was the hiccup? Where else? Nowhere else? Ladies? You all look like you got hit by a bus. Let me help you out. Let's take the bus and not hit you again. So where did it go wrong?
We just forgot to do the y and divided by y. We just got negative x, and then we did that.
That's an easy fix, though. That's an easy fix.
For 24 hours.
You got 24 hours. That is truly is an easy fix. It's just a forgetting to do one step versus I have no idea what the heck is going on. So that's an easy fix. What else? Is that it? Okay, related rates. This is like the best we'll ever have. So in this section, this is not on the test. It's on the next test, so it's not on the test tomorrow. So in this section, what we're doing is we're actually using derivatives. And more often than not, we are doing it with respect to time. So every single variable that we do the derivative on will be with respect to time, because we want to know what's happening over some time interval. We want to know what the rate is at some specific time, so we need to know the change of that specific variable. So everything is going to be in terms of dt. So first we're just going to start out with just finding some implicit and doing some derivatives. So I want to find dy dt at x equals 1 and y equals x squared plus 3. And if dx dt is equal to 4. So all of these are going to be with respect to time. So when I do my derivative, I do my derivatives, all the regular derivative rules like I did before, but instead of with respect to x, it's going to be with respect to time. So when I do the derivative of y is equal to x squared plus 3, my constants, even with respect to time, will still be 0. So that's nothing there has changed. But what has changed is before we'd write dy dt or y prime. That is with respect to x. So if we had, before we had y prime, that was with respect to x. Now we're going to do it with respect to time. So we do the derivative of y with respect to time. We do the derivative of x with respect to time. And then we do the derivative of 3 with respect to time. But that's still going to be 0. So that part hasn't changed. What has changed now is that I now have dy dt is equal to 2x dx dt. Up until now, we didn't have to worry about the dx dx because equivalently that's 1. Now I have to worry about it. And the way in which I worry about it now is I'm going to put in the information that I have. I'm trying to find dy dt. They're telling me what x is, so I do a replacement wherever x, I replace it with that value, and then I replace dx dt with 4. So this gets replaced with the 1, and this gets replaced with the 4. So if I'm asked for dy dt, then this is going to be equal to 2 multiplied by 1 multiplied by 4, so my answer is 8. And it's going to have some units with respect to time. So if this particular function y equals x squared plus 3 represented a distance traveled, then my units will be, say, meters per second, because it is a unit of time. So I need to know what the time unit is. I'm just making up, in this case, seconds. So it could have been in minutes, it could have been in hours. And it has to have some kind of other unit with it. It could be the volume changing with respect to time. It could be the height changing with respect to time. It could be money changing with respect to time. But it's always with respect to time. Is there any questions? I'm going to stop. I'm going to let you, I'm going to just record that. So the question was, dy dt and dx dt are separate. They are separate. So in the past, what we've done is with respect to x. So our dy dx was always there, but our dx dx wasn't because it's equivalently 1. But now, unless I have a variable of time, then everything is going to be with respect to time. So instead of just having just y prime equals, equivalently you have something like y prime equals some x prime is going to be in there too. So everything is going to be with respect to time. So all of those derivatives with respect to time are going to be there until we do replacements. Again, I'm going to let you just kind of stare at it. So the question was, will I always be given dy dt or dx dt? Yes. I will always be giving enough information, and I'm always on related rates solving for one of the variables with respect to time, and I will know the other variables with respect to time. And I will plug those in at the very end. Any other questions? Okay, go ahead and try the second one on your own, and then we'll go through it. So for this one, I'm not given z, but I'll need to find z. I'm not given it explicitly, unlike x and y. I have x and y, but I don't have z explicitly. And I know when I do the derivative, I'm going to have a z term in there. So I need to find z. So the first thing I'm going to do is find z. So z squared is going to equal to 1 squared plus 3 squared. That's the first thing I'm going to do. So z squared is going to be equal to 1 plus 9. So z is equal to plus and minus the square root of 10. Now I needed that because of the fact that when I do my derivative, I'm going to have a z value with it besides the dz dt. So let's do the derivative with respect to time. I start out with z squared is equal to x squared plus y squared. So I'm going to do each one of these derivatives with respect to time. So it'll be 2z dz dt. So the derivative of z with respect to time is equal to 2x dx dt plus 2y dy dt. How was that? Did you all get to that point? If you didn't, that's okay. All right. So now I have a replacement for dy. This dy I get to replace with 3. dx dt I get to replace with 4. My x I get to replace with 1. My y I get to replace with 3. And this is what I had to find my z. My z I can replace with plus and minus the square root of 10. Okay? So what I have then is 2, and I'm just going to use the positive because if you hadn't already recognized it, that was a Pythagorean identity. So of course distances are not going to be negative. So I'm just going to use the positive of it because it is the Pythagorean identity. So dz dt. On the other side of the equal sign, I have replacements for all of my variables, including my dx dt and dy dt. So it'll be 2, 1 multiplied by 4, plus 2 multiplied by 3 multiplied by 3. How are we doing? Doing okay? All right. So I have 10 root 2 root 10 dz dt. And then on the other side of the equal sign, what does this add up to? 26? Now I'm going to divide both sides by 2 and the square root of 10. And so I end up with 13 over the square root of 10. That's my final answer. Divide both sides by 2. So 26 gets reduced by 2, and the square root of 10 is just coming along for the ride. You do not need to rationalize in this class. You can if you want to. All right. Is there any questions on this one?
Can we have one more problem like this? Because I got confused about how am I supposed to solve C. I just went straight doing that.
Sure, absolutely. Let me give you another one then. Let me get rid of this work over here and let me give you a second one. So, do you want 3 variables or 2 variables?
3 variables.
Okay. So 3z squared is equal to x plus 2y squared. Dx dt is equal to 1. dy dt is equal to 5. And it's going to go through the ordered pair. Oh, let's make this a nice number. Let me see. 3 and I'm going to need this to be a nice number. I know it's going to go through 1 and 4. So it's going to go through the point 1, 4, or 4, 1. I want it to be nice numbers. Do this one. What am I going to do first?
Solve for Z.
So I'm going to do the derivative, right? Or I'm going to solve for z. So I'm going to need to solve for z because I'll need that as part of my derivative. So when I solve for z, I'm going to put in these values, 4 wherever I see x and 1 wherever I see y. So I've got 3z squared is equal to 1 or 4 plus 2 times 1. So 3z squared is equal to 6. So z squared is equal to 2. So z is equal to, and I'm just going to tell you to take the positive. Normally we should put the plus and minus, but I just want you to take the positive. Okay? So now what? I found z, now what?
You solve for dz over dt.
How do I solve for dz dt? I don't even see that.
Take the derivative.
I have to take the derivative. So the intermediate step is I have to find the derivative. So I'm going to have 6z dz dt is equal to dx dt plus 4y dy dz. That's a really bad looking y. Okay, now what?
And we plug in the values.
I plug in the values. I don't take the time to find dz dt in terms of everything else. I'm just going to plug the values in right now because I'm less likely to make mistakes if I see the numbers. So I'm going to replace z with the square root of 2, dz dt. dx dt is what?
1.
What was y?
1.
What was dy dz?
5.
Okay, so I have 6 the square root of 2 dz dt. What is the other side of the equal sign add up to? Now what? So now I do that division, dz dt, and 6 and 21 will reduce by factors of 3, so it's going to be 7 over 2 square root of 2. How was that? Yes.
Much better.
That's
The
a-
dy dz, is that supposed to be dy dt? At the for the y?
Oh, yeah. Thank you. Yeah. Let me get rid of that. That should be a T. Thank you. I probably said T and put a Z there. You never know. Pretty sketchy. Gotta watch me. I'm sketchy. Okay, how was that?
Much better.
Okay. So now that you got a feel for it, we're all going to be using this information to start solving our application problems. So we're going to spend quite a bit of time applying our derivatives. In fact, that's pretty much chapter 4 is applying derivatives. We start out with the related rates. So the first thing you want to do is read through the problem and draw a diagram. It's going to help you so much better if you draw a diagram. Now, there are going to be certain quantities that are not going to change, and there are going to be certain values that do. And then we're going to talk about directionality as well as we go through these problems. Now, I always write down what I'm looking for. In this case, those examples I had there, I was looking for either dy dt or dz dt. When I read through the application problem, I need to figure out, am I looking for the change in height with respect to time, or am I looking for the change of volume with respect to time? What am I looking for? So I always note that somewhere. I need to find as many equations as I need to write it in such a way that I have replacements for everything. So if I have the volume of a cone, which is 1/3 pi r squared h, and I don't have h, then I got to figure out how to do a replacement for h. If I don't have r, then I need to do a replacement for r. And then I'm going to implicitly differentiate like we did on these first 3 examples. I'm going to do it with respect to time. So every single one of my variables will have a dy or have a dt with respect to time. Then I'm going to state my final answer in a way that makes sense. I don't just write the answer as 2/3. 2/3 what? All of these will have units attached to them. So all the ones that we are going to be doing will have units attached to them. So I'm going to go ahead and pause this in case you are writing this down. I'll let you have the opportunity to write it down, so I'll pause this. If we take a look at some hints, there are some hints you want to do is you always want to check your units. So your units are going to tell you whether or not you did something right or not. The other thing is do not plug any of the constants in until the very end. Plug in the constants at the very end. Certain things are not going to change, so you don't have to worry about putting those numbers in, but don't put them in until the end. Because if you put them in before then, what will happen is that you will have lost that number, and that's going to be really, really, really bad. Now, all your units are going to be with respect to time, so pay attention to your units. Flog those units like no other. So we're going to do this first one, and it's going to be the best we've ever had in our entire lives. It is the best we've ever had in our entire lives. So, I want you to read the first one, and I'm going to put this on pause, and I just want you to read through it. Fast is the height increasing? So the key word is how fast the height is increasing. So what I'm trying to find, this is my goal, is I need to find dh dt. That's what I'm trying to find. Now, the actual differentiation is going to be easy for you all. The plug in the numbers in are going to be easy for you all. The thing that's going to be the bus that hits you and runs you over a couple of hundred times is finding the right relationships and the right equations to make this work. So I look at this and they're giving me some information. I have the tank is an upside down pyramid, the base of 4 by 4 and a height of 12. How fast does the height increase when the water is 2 feet deep and is being pumped in at 2/3 of a meter per second? So that 2/3 meter per second is a volume information. So right now we know we have a volume of 2/3 meter per second. And that actually should be meters cubed per second.
So the function is not going to be given to us, we have to derive.
The function will not be given to you. It is, and that's where the bus hits you a couple hundred times. Backwards and forwards and backwards and forwards, and drags you down the hill and drags you back up the hill.
So we find the volume function for this right here.
So we're going to find the volume function, and that's based on the fact that they're giving me the volume. Actually, what they're giving me is dV dt. So what they're actually giving me is the volume is changing with respect to time by 2/3 of a meter cubed per second. That is the change of the volume with respect to time. Yes. So now I need to find the volume formula. So my volume formula for this is 1/3 the area of my base, which happens to, we'll just call it area of base. I'll just do it that way, multiplied by the height. So that is the formula for a pyramid. Now, the area of my base, we're just going to call it, what do you want to call it, X? Do you want to call it B? What do you all want to call it? Okay, we'll call it A. But we're going to call it not just A, because it's an area thing, we're going to call it A squared. So A times A, or X times X, or B times B. I don't care how you call it that. So my base, my area of my base is going to be B times B, or B squared, or A squared, or X squared, or whatever in the heck you want to use. Okay? So now my formula is this. Volume is equal to 1/3 B squared times H. I'm trying to find dH dt. They give me dV dt. Do they give me anything about the base? They give me a dB dt. Do I have the change in the base with respect to time? It is not given to me. So what I have to do is I have to relate my base and my height to each other so I can get a replacement. I have to relate my base to my height. So I'm just going to do a cross-sectional area of my shape. So it's a triangle. The cross-sectional area of my shape is a triangle. The height of my original shape is a total of 12. My base width is a total of 4.
Did you have to find the slide height?
Nope. Cross-sectional area. So what they're asking me to do, though, is they want to find the height at a given time. The height they're asking me to find, or the change in the height they're asking me to find, is when the height is 2 meters deep. So I know that this is equal to 2. That particular height is equal to 2. I don't know what that base is, but I certainly can find a relationship there. So this here is going to be, we'll call it X. So now these are similar triangles. So everything you forgot in your high school math is going to rear its ugly head in calculus if you haven't already seen that. Everything you forgot is here. It's in this one problem. So I'm going to do this by similar triangles. And so I know that 2 is to 12 as X is to 4. Do you all agree to that? 2 is to 12 as X is to 4. We cool with that? So X is equal to what? 2/3. Do y'all agree it's 2/3?
Wait, how did you get 2 by 12?
So I'm using similar triangles. So similar triangles say that I have this relationship, and I know they're similar triangles because I can embed one triangle inside the other. And that my bases are running parallel. So I put my height to one triangle to the height of my other triangle, my base to one triangle to the base of my other. So I have 2 is to 12 as x is to 4.
That makes more sense.
Okay? Now, what I did now is I found the constant for a replacement. I did not, however, find it in terms of my height. So I need to take and do the same thing again, but now I'm going to do it in terms of my height. So in general, my 12, which is x, we had that as b. b is to 12 as my height is to, oh wait, so it is h is to 2. H is to 12 as my base is to 4. So remember, I am trying to replace out my base. I'm trying to replace out my base. So I'm going to solve for B or H. I'm trying to replace out my base. I solve for B. So solve for B.
But didn't you already solve it for B?
I solved a constant. I don't want to put the constant in. I solved for a constant. I do not want to put that in. So when you solve for B, what do you have?
1/3.
So 1/3 H is equal to B. Now I'm going to go and put that back into my volume formula. So V is equal to 1/3 H squared times H. How are we doing? This is the bus. Getting used to being ran over. We're digging it. Okay, so where I am now is I have the volume is equal to 1/27, because I have to square the 3 in the denominator, and then H cubed. Now I have a replacement for dV dt. I have a replacement for the height, and I am solving for dH dt. So take the derivative now with respect to time. So I'm going to do the derivative with respect to time, and so I've got dV dt is equal to 1/27 multiplied by 3h squared dH dt. Do I have a replacement for dV dt? Yes. Do I have a replacement for h?
Yes.
Yes. What am I chasing? dH dt. So my dV dt is 2/3. So this is 2/3. This is 1/9. 27, 1/27 multiplied by 3 is 1/9. My h was 2 squared. My dH dt is what I'm solving for.
Why are we using 2 as our height?
Because we want to know how quickly the height is changing when the height is 2. Okay?
And the dV is the rate change.
Yep, of the volume.
So basically everything was given to us in the thing itself. We just had to find the constant and the
Yes. So everything was given to us, just not nicely. It's all embedded into it. So I end up with 2/3 is equal to 4/9 dH dt. I'm going to multiply both sides by the reciprocal of 4/9. So I'm going to multiply both sides by 9/4. So I'm going to multiply this by 9/4. I'm going to multiply this by 9/4. And I end up with
18 over 12.
18 over
12. So 3/2.
3/2 and that is my dH dt. What do you think my unit should be on that?
Meters per second.
Meters per second. So my final answer is the height is changing 3/2 meters per second when the height is 2 meters. All right, how was that?
I mean, it was lengthy. Yeah, I feel like if we did more problems, we
Let's
would
do another one.
have it.
Let's at least set up another one. Okay. A 10-foot ladder is leaning against the wall. If the top of the ladder slides down at a rate of 2 meters per second, how fast is the bottom moving along the ground when the bottom of the ladder is 5 feet from the wall?
Enough to kill a math student.
Enough to kill a math student? No. So, as we read through this, what am I hoping to find?
The rate of it falling in feet per second.
Do I want a rate of the top of the ladder? Do I want a rate of the bottom of the ladder?
5 feet from the wall.
How fast is the bottom changing?
We don't.
So that's what we're searching for. We are searching for that. So let's throw in some variables. What do you all want to call across the bottom? What do you all want to call across the top, the wall? You all are bawling out of control. So what am I chasing then? DH/dt or dB/dt? So I want, I put an H in there, that's nice. I want dB/dt. What am I given? I am giving the slides down at a rate of 2, so I'm given dH/dt. What else am I given?
Oh my God. It's that part that's sliding away. You want to see how far is it when it slides away 5 feet away from the wall. Yeah, I just got it.
You're tracking. Cool. Cool. Okay, we want dB/dt. We are given dH/dt. What kind of formula do you think I need here?
A squared is equal to B squared plus C squared.
Bam. Quadratic form, or the Pythagorean theorem. Bam. So it is going to be h squared plus b squared is equal to 10 squared. Now what? Do we have to do these shenanigans in terms of replacements? Do we have to shenanigate?
We have to find the derivative first.
I do have to find, and I know, here's a constant that's given to me that I'll put in the end. I do know that that is 5. Do I need to find h?
Yes.
I will need to find h too. I will put it in at the end, but I still need to find h. So how do I find h?
H is equal to 5 squared plus h plus 5 is equal to 10 squared, so just solve it for h. Yeah.
Okay, so solve it for h.
H squared is 75. So h is the square root of 75.
Okay, now let's go back to here and differentiate, please. So do a quick differentiation. Yes?
How do we know B is 5?
Because we want to know the rate at which this thing is falling from the ground, or the rate at which the base is moving when the top is falling at a rate of 2 feet per second. So at 5, when it's 5 feet from the wall, we are given that part. I told you this is the bus hitting you. Okay, so you get 2h dH dt plus 2b dB dt is equal to 0. Now, what's going to happen is we have to talk about directionality. If we are going down, that means negative. If we are moving away, that means negative. So if you come up with negatives, that doesn't mean it's wrong. It just means your directions are now involved in this. So you're going to have directions involved with it as well. So once you do that, you just plug everything back in and you get an answer. It's like square root of 3 or something. Have a great day. We'll pick this up again on Monday after the test.